Welcome to AI Tech Book, the Atlas, Episode 2, Tool Use. But before the intro, one number, then we'll set up what's ahead. Anthropic publishes one number every team building agents on Claude should memorize. Parallel tool calls cut total time by up to 90% for complex queries. That's not a benchmark someone ran on a side project. That's from Anthropic's own engineering blog on the multi-agent research system they ship in production. And most teams aren't getting that lift. Not because they didn't try parallelization, because their tools are defined wrong before the first request even goes out. 5 mistakes. Each one in Anthropic's own documentation, with the exact passage and the fix. About 16 minutes. If you've shipped a Claude agent and watched it choose the wrong tool, or watched it never call a tool at all, or watched it burn 15 times the tokens of a chat for a result that wasn't 15 times better, at least one of these mistakes is yours. Probably more. Tool use is a 4-field contract. Tools is the array of definitions you send to Claude. Each definition has a name, a description, and an input underscore schema. The 4th field is tool underscore choice, auto, any, tool, or none, which controls when Claude is allowed to call a tool. That's the whole API surface for tool use. 4 fields. When Claude decides to call a tool, you get a response with stop underscore reason equals tool underscore use, and one or more tool underscore use blocks containing the tool name and a JSON object of arguments. Your application code executes the operation. You send back a tool underscore result block. Then the loop continues. That handoff, request, tool underscore use, execute, tool underscore result, repeat, is the agent loop. Anthropic's docs describe it as a while loop, keyed on stop underscore reason. We'll get to it in mistake 4, where most teams ship it broken. Each of the 5 mistakes lives in one of those 4 fields, or in the loop around them. The first field everyone underestimates is description. It looks like a label. It's not. Anthropic's own guidance is unambiguous about which field matters most, and it's not the one most teams spend time on. Mistake 1. Underspec'd descriptions. Quote, Anthropic, verbatim from the tool use documentation, detailed descriptions are, quote, by far the most important factor in tool performance, end quote. By far. Not important. Not matters a lot. By far the most important factor. The same docs say, aim for at least 3 to 4 sentences per tool description. More if the tool is complex. A good description tells Claude 4 things: what the tool does, when to use it, when not to use it, and what each parameter means and how it affects the tool's behavior. Anthropic publishes a side-by-side example. The good one is 6 lines. It describes the get underscore stock underscore price tool, quote, retrieves the current stock price for a given ticker symbol. The ticker symbol must be a valid symbol for a publicly traded company on a major US stock exchange like NYSE or NASDAQ. The tool will return the latest trade price in USD. It should be used when the user asks about the current or most recent price. It will not provide any other information. The bad one is 1 line, gets the stock price for a ticker. That's it. Claude has to guess every edge case. Which exchanges? Which currencies? What gets returned? What doesn't? Underspec'd descriptions don't just hurt selection. Every wrong tool call eats tokens, eats latency, and chains into the wrong follow-up calls. The fix is the cheapest thing in the entire production stack. Write the description like you're onboarding a contractor who has the JSON schema but none of the context. That's mistake 1 handled. Next field where teams ship the bug, the surface area itself. Mistake 2. Bloated tool surface. More tools is not more capability. Anthropic's locked guidance from the same defined tools page, quote, consolidate related operations into fewer tools, end quote. Rather than create underscore PR, review underscore PR, and merge underscore PR as 3 separate tools, group them into one tool with an action parameter. That's the published example. Why this matters? Fewer, more capable tools reduce selection ambiguity. The model picks faster, picks more reliably, and your tool surface stays navigable as the library grows. 3 narrow tools that overlap force Claude to disambiguate every call. 1 wide tool with an action enum lets the model do what it's good at, pattern match the action to the user intent. There's a corollary for schemas. When your tool inputs get complex, nested objects, format-sensitive parameters, Anthropic shipped a field in 2026 exactly for this. It's called input_examples. Schema validated examples attached to the tool definition that teach Claude the patterns. 20 to 50 tokens for a simple example. Up to 200 tokens for complex nested objects. Use input_examples when your schema is non-obvious. Don't try to encode the patterns in the description prose. The model has been trained on input_examples specifically. Anthropic's docs are explicit that examples show concrete patterns for well-formed tool calls. And use namespacing in tool names when you have tools across multiple services. The example Anthropic ships GitHub_list_pres Slack_send_message. The prefix removes ambiguity at the name level before description even matters. That's mistake 2. Now we get to the stat from the hook. The one most teams leave on the table, sequential calls when parallel would work. Mistake 3. Sequential when parallel works. The 90% number from the hook lives here. Anthropic's exact words from the Multi-Agent Research System blog, quote, parallel tool calling transform speed and performance, end quote. 2 parallelization patterns Anthropic ships in production. Pattern 1. The lead agent spins up 3 to 5 subagents in parallel, not serially. Pattern 2. Each subagent uses 3 or more tools in parallel. Quote, those changes cut research time by up to 90% for complex queries, end quote. Up to 90 for complex queries. Not all queries, but the ones where it matters, the ones with 3 or more independent lookups, the ones where sequential adds up to seconds you can't justify. One cost reality check before we move on. Multi-agent systems use about 15 times more tokens than chat interactions. Single agent agents use about 4 times more. That's Anthropic's measurement. From the same blog. 15x is real. The trade is real. Parallel tools plus prompt caching is the architecture that earns that budget, and we'll get to catching in mistake 5. The mistake team ship, if you're calling tools in a for loop, you're paying full latency for every step. The model is happy to plan 3 parallel calls in one turn. Your code has to be ready to execute them in parallel. Most code isn't. Check your tool runner. If it serializes tool_use blocks one at a time, you're shipping the bug. The fix is concurrent execution. Promise.all, AS, Y, N, C, IO, .gather, whatever your language gives you, then return all the tool_result blocks in a single follow-up request. Halfway through. 2 mistakes still to come, and they're the ones that turn into Slack postmortems. Quick word from the channel, then mistake 4. If this is useful, subscribe to AI Techbook. The Atlas Episode 3 is context engineering. Same format, same depth, same Anthropic source playbook. The 15 times tokens problem from mistake 3? Episode 3 is the answer? 1 subscribe button. Now, mistake 4. The one that makes your agent silently never run its tools. Mistake 4. Treating tool_use as the answer. When Claude wants to call a tool, the response comes back with stop_reason equals tool_use and 1 or more tool_use blocks. Your code is supposed to execute the tool and feed the result back. The model never sees the tool's output unless you do that. The canonical loop from Anthropic's How Tool Use Works docs is 5 steps. 1. Send the request with your tools array and the user message. 2. Claude responds with stop_reason equals tool_use and 1 or more tool_use blocks. 3. Execute each tool. Format the outputs as tool_result blocks. 4. Send a new request containing the original messages, the assistance response, and a user message with the tool_result blocks. 5. Repeat from step 2 while stop_reason is still tool_use. The loop exits on any other stop reason, end_turn, max_tokens, stop_sequence, or refusal. The mistake team ship, they treat the tool_use block as the final answer. They render it to the user. The tool never runs. The model never sees the result. No error, no exception, no stack trace. Just a tool_use block that should have been a round trip. If you've ever debugged an agent that did nothing, checked the logs, saw a clean 200 response. This is the bug. The fix is the while loop. Don't write tool using code without the loop. Even for a single tool call, the loop is the contract. And while you're in the tool definition, set strict equals true. From the Anthropic docs, quote, add strict true to your tool definitions to ensure Claude's tool calls always match your schema exactly. End quote. If you're parsing tool inputs with try-catch and validators downstream, you're missing this. Strict mode makes the schema the contract, not the suggestion. One mistake left, and it's the most expensive one to ship and not catch. Mistake 5. Tool definitions outside the catch prefix. Prompt caching references the prompt in 3 layers in order: tools, then system, then messages, up to and including the block you mark with cache_control. Tool definitions are the first cache level, before system prompt, before any user message, the first thing the cache looks at, which means every time you change a tool name, description, or parameter, you invalidate the entire cache. Quote Anthropic, changes at each level invalidate that level and all subsequent levels. End quote. Tools is the first level. Any change to tools blows away the cache for tools, system, and messages. The entire prefix. Every byte. Full price on the next request. The bug team ship, they rebuild tool definitions in code on every request. The tool array looks identical, but the JSON serialization order changes between runs. Or a description has a trailing space one day and not the next. Or a parameter description got tweaked by a teammate who didn't realize. Cache miss. Every request. Full input price. No 0.1x cache read pricing. And the red pricing is the whole game. Cache reads are 0.1 times the base input price. Cache writes are 1.25 times the base. That's a 10x swing on every cache token. At 15x token usage for multi-agent, caching is what makes that math survivable. Without caching, you're shipping a system that costs 15 times more than chat for the same conversation. The fix has 3 parts. 1. Build tool definitions once at startup. Lock them. Treat them as immutable for the conversation. 2. If you have to rotate tools mid-conversation, rotate the whole cache. Don't pretend you're saving anything by swapping a single tool. The cache is gone either way, except the rebuild. 3. Diff your tool's serialization output across runs. If 2 identical-looking calls produce different JSON bytes, your cache hits are accidental. That's not engineering, that's luck. Sort keys, strip whitespace, lock the serializer. 5 mistakes. Now, the failure modes Anthropic documented from running this in production. The trap. 3 documented failure modes Anthropic shipped in production. These are paraphrased from their own engineering blog, not hypothetical bugs, things they actually observed and had to engineer around. 1. Spawning 50 subagents for simple queries. Anthropic's exact words, quote, early agents made errors like spawning 50 subagents for simple queries, scouring the web endlessly for non-existent sources. End quote. 50. For a query that needed one. The model's optimization function doesn't penalize over spawning unless you build the penalty in. Cap subagent counts explicitly. Don't trust the model to right size by default. 2. Agents distracting each other with excessive updates. Same blog. Coordination overhead exceeding the actual work. Subagents posting status updates that other subagents had to process. Compute spent on coordination, not progress. The fix Anthropic shipped was structured handoff, not more chat between agents. 3. Consistently choosing SEO optimized content farms over authoritative sources. Quote, human testers noticed that our early agents consistently chose SEO optimized content farms over authoritative, but less highly ranked sources like academic PDFs or personal blogs. End quote. The model defaulted to easy retrieval over good retrieval. Whatever ranked first won, even when ranked first was a content farm, and the actual authority was 3 results down. 3 failures. Each one is a feature of the model class, not a bug in one team's code. Plan for them in the architecture, not in the prompt. What this means for you depends on which seat you're in. If you're an architect, mistake 5 will bite first. Cache invalidation from tool definition churn is the silent cost line item nobody attributes correctly. The bill goes up, the conversation logic didn't change, nobody can explain it. Audit the tool serialization path before you audit anything else. Lock the definitions. Sort the keys. Make cache hits deterministic. And if you're a developer, mistake 4 is the one that ships without a stack trace. Write the while loop on stop_reason before you write the first tool. Treat the tool_use block as a function call, not a response. And turn on strict equals true. The schema is your contract. Don't rely on downstream validators to catch what strict catches upstream. If you're a technical PM, so mistake 3 is the demo. Sequential agents look slower than they need to. The 15 times token stat is the budget reality. Parallel tools plus prompt catching is the architecture that earns the budget. If your team is debating whether to ship an agent, the answer is rarely whether, the answer is which architecture makes the unit economics work. Mistake 3 plus mistake 5 together are that architecture. 5 mistakes. 5 things to check before your next agent ships. 5 mistakes. 5 fixes. From the Playbook Anthropic ships. 1. Underspec'd descriptions. 3 to 4 sentences minimum. 2. Bloated tool surface. Consolidate. Use input_examples. 3. Sequential when parallel works. 3 to 5 subagents, each using 3 or more tools. 4. No stop_reason loop. While stop_reason equals tool_use, keep going. 5. Definitions outside the cache prefix. Lock tools at startup. That's the playbook.